Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an isometric 3D projection of a solid into which the front face, the right hand side view face and the top view face of the solid, they have been clubbed into a single 3D isometric projection over here. So now we are required to convert this 3D isometric projection corresponding to this object into three orthographic views of the object over here. Now we are required to obtain the front view orthographic projections, the top view orthographic projections and the right hand side view orthographic projections of this engineering construction over here. In order to obtain the orthographic projections of this object, let us first of all evaluate the dimensions of the front view face, the right hand side view face and the top view face of the orthographic projections over here. As we look at this object from the front view orientation, now we observe that the width of the object happens to be equal to 50 millimeter, while the height of the object happens to be 58 millimeter. So the dimensions of the front view projections, it will be 50 millimeter width and 58 millimeter height over here. Similarly, when we look at this object from the top view orientation, then we observe that the width of the solid happens to be 50 millimeter, while the depth of the solid happens to be 40 millimeter. So the top view orthographic projection dimension will be 50 millimeter will be the width and 40 millimeter will be the depth of the object over here. Similarly, as we are going to look at this object from the right hand side orientation, then we observe that the depth of the solid happens to be 40 millimeter, while the height of the solid happens to be 58 millimeter. So the dimensions of the right hand side view face corresponding to the solid will be 40 millimeter will be the depth of the solid and 58 millimeter will be the height of the orthographic projections over here. So with this information, let us proceed to evaluate the front view, the top view and the right hand side view orthographic projections of this particular solid. Now since we are going to obtain these orthographic projections into the first angle projection, so the front view will be obtained above the XY reference line, top view will be obtained below the XY reference line and the right hand side view projection of the solid, they will be obtained on the left hand side of the front view projections over here. So here we have drawn the XY reference line and the X1 Y1 reference line over here, and we have also drawn this transfer line. Now here using this transfer line, we are going to convert the distances which are obtained into the top view projections alongside the depth of the solid into the right hand side view projections over here. Now we know that into the front view, the dimensions of the orthographic projection face will be 50 millimeter width and 58 millimeter height. So we know that the width of the solid happens to be 50 millimeter. So now we have drawn two projection lines which are separated by the distance equal to 50 millimeter, which happens to be the width of the solid. And we also know that the height of the solid, it happens to be 58 millimeter. So now we have marked 58 millimeter height of the solid, and again another horizontal projection line we have drawn into the front view projections, which we have further extended it into the right hand side view projections over here. So now this way we have been able to obtain the front view face of this particular solid, which is measuring 50 millimeter by 58 millimeter. Now as we are going to look at the solid from the top side, so we observe that once again the width of the solid happens to be 50 millimeter, while the depth of the solid, it happens to be 40 millimeter. So into the top view projections, we have obtained the width of the solid equal to 50 millimeter over here, and we have drawn two projector lines over here which are separated by the distance 40 millimeter, which happens to be the depth of the solid. So this way we have been able to obtain the top view orthographic face over here, which is going to measure 50 millimeter by 40 millimeter over here. Now we have extended these two horizontal projectors which we have marked into the top view projections through this transfer line into the right hand side view projections over here. So using this transfer line, we have been able to convert this depth of the solid is equal to 40 millimeter into the right hand side view projections over here. So we can now observe that into the right hand side view projections, the depth of the solid, it happens to be equal to 40 millimeter, while the height of the solid happens to be equal to 58 millimeter. So this way we have been able to obtain the boundaries corresponding to the front view face, the top view face, and the right hand side view face over here into the orthographic view projections. Now let us look at the construction of the solid and let us obtain the different elements of this particular solid from the front view side, from the top view side, and from the right hand side view side orientation over here. So now we observe that into this solid we have got two horizontal webs. They are available. One horizontal web, it is available at the base, which happens to be an inclined web. Again, there is a horizontal web which happens to lie at the top portion of the solid, and the third element of the solid happens to be a vertical web which happens to lie onto the rear side of the solid over here. So as we look at the solid from the front, so we observe that this horizontal web which happens to lie at the top surface, it is having height is equal to 10 millimeter. So by marking a 10 millimeter distance from the top face of the solid, we have drawn a projection line into the front view projections and extended this projection line into the right hand side view projections over here. Now we know that further this horizontal web has been divided into three segments over here. So corresponding to these three segments, we know the dimension. So the total width of this edge, it happens to be 50 millimeter, out of which this portion of the web, it is going to measure 15 millimeter width. Similarly, corresponding to this slot, we have got the measurement regarding the width of the slot equal to 20 millimeter. So automatically this distance will again be 15 millimeter. So we have marked this distance 15 millimeter width over here, and similarly we have marked this width of 20 millimeter corresponding to this slot over here. And now we have drawn two vertical projector lines into the front view projections, and we have extended these vertical projection lines into the top view projections over here. So now we have been able to obtain all the three segments corresponding to this horizontal web which is available with us at the top surface of the solid, having thickness or the height equal to 10 millimeter over here. Now we also know that corresponding to the bottom portion of this horizontal web, which happens to be an inclined web over here. So corresponding to this inclined web which is existing at the bottom, at the back we are going to have the height of this web, it is equal to 15 millimeter. So this surface of the web will be visible to the observer as the observer is going to look at the solid from the front view orientation over here. So now we have marked this distance of 15 millimeter above the ground, and corresponding to this distance of 15 millimeter above the ground, again we have drawn a horizontal projector line into the front view projections, and we have extended this horizontal projector line into the right hand side view projections over here. So through this projector line, we will be able to visualize this edge of the solid over here into the front view projection. Similarly, since this surface which is available corresponding to the bottom horizontal wave, so this happens to be an inclined surface over here. So into the front face, we observe that the height or the thickness of this web, it happens to be equal to 5 millimeter over here. So corresponding to this thickness of 5 millimeter, again we are going to draw the distance of 5 millimeter from the base into the front view projections over here, and another horizontal projector line we are going to draw into the front view projections and extend this horizontal projector line into the right hand side view projections over here. So this way we have been able to divide this object into different elements as the observer is going to look at the solid from the front view orientation over here. So now let us darken the different segments of this object which will be visible to the observer as the observer is going to look at the solid from the front side. So now we see that observer will be able to visualize this boundary of the object over here. Why? Because this vertical segment, this inclined segment, again this vertical segment and this vertical segment over here. So all these segments, they will be visible to the observer. So we are going to obtain a vertical projection line on the left hand side. Similarly, corresponding to the right hand side face of this object, this portion will be visible, which is a vertical one. This inclined portion of the object will be visible to the observer. This vertical portion of the object will be visible to the observer, and this vertical face of the object will be visible to the observer. So this way, one vertical projector line we have been able to obtain into the front view projection over here, corresponding to the right hand side face of this object over here. Similarly, this top face of the object will also be visible to the observer. And now we know that corresponding to this top face horizontal web which we are going to have at the top surface, carrying a rectangular slot at the center of this horizontal web. So this horizontal surface will be visible to the observer over here. So this is the base of this horizontal web which is lying at the top surface of the solid. So this base will be visible to the observer. Now we can check that there are three segments which will be visible to the observer as the observer is going to look at the solid from the front side. So this portion, and this is a rectangular portion which is visible to the observer. So now we have been able to obtain shape of this portion of the web over here. So into the front view projections, the observer will be able to view the rectangular projections corresponding to this face of the top surface web over here. Similarly, this portion of the top surface web, the true shape projections corresponding to this portion of the top surface web into the front view projections over here. Whereas corresponding to the slot, the observer will be able to visualize true shape projections into the front view orthographic projection over here. Similarly, next we can check, this is the vertical rectangular web which the observer will be able to visualize into the front view projection. Now since this vertical face of the web, it happens to be parallel to the vertical plane, so observer will be able to visualize the true shape of this vertical web into the front view projections over here. Next, the observer will be able to visualize this inclined surface of the solid over here. So corresponding to this inclined surface of the solid, which is inclined with respect to the vertical plane, now the observer will be able to visualize only limited portion of this web as front view projections over here. So we can observe over here, this is going to be the apparent shape of the big surface which we have obtained over here. So corresponding to this big inclined surface, the observer is able to visualize apparent shape projections into the front view projections over here. And finally, we have got one vertical web which is going to measure 5 millimeter height and 50 millimeter width over here. Since this surface happens to be parallel to the vertical plane, so observer will be able to view the true shape projections corresponding to this front face of the vertical web into the front view projections over here. Now let us proceed to evaluate the top view projections of this engineering object over here. So as we are going to look at the solid from the top, we observe that this depth of the vertical web which is lying at the rear surface of the solid, it happens to be equal to 10 millimeter. So we know that this is the rear surface of the solid. So from the rear surface of the solid into the top view projections, we have marked a distance of 10 millimeter. So corresponding to this vertical web, we know that this depth happens to be equal to 10 millimeter. So we have drawn a horizontal projector line corresponding to the depth of this web equal to 10 millimeter into the top view projections, and we have transferred this distance of 10 millimeter from the rear face into the right hand side view projections view over here using this transfer line. So now we know that as the observer is going to look at the solid from the top, the observer will be first of all visualizing this top portion of the horizontal web over here, which is carrying a central rectangular slot over here. So we know that the dimension corresponding to this slot, it happens to be 18 millimeter from the rear face of the solid over here. So now we have marked this distance of 18 millimeter from the rear face of the solid, and again we have drawn a horizontal projector line which is going to decide this particular portion of the rectangular slot which is available onto the top face horizontal web over here, and we have transferred this distance into the right hand side view projection view using the transfer line over here. This is the transfer line. Similarly, we know that this depth of this top horizontal web, it happens to be equal to 28 millimeter. So we have marked this distance of 28 millimeter from the rear surface of the solid over here, and we have again drawn a horizontal projector line into the top view projections and transfer this distance into the right hand side view projections over here using this transfer line. Let us now evaluate different elements of this top surface horizontal web which is carrying a central rectangular slot over here. So now we can see this portion of the top surface web will be visible to the observer, and at a distance of 28 millimeter from the rear face, this will be the front face of the top horizontal web over here. Now this top surface web, it is carrying a central rectangular slot over here. So this slot, it will be available at a distance of 18 millimeter from the rear surface of the solid, and this depth of the slot will be equal to 10 millimeter. So this depth happens to be 10 millimeter. This width of the slot happens to be equal to 20 millimeter. So this way, the projections corresponding to the top surface of the slot, we have been able to obtain over here. And since this surface happens to be parallel to the horizontal plane, so into the top view projections, we have been able to obtain the true shape projections corresponding to this surface over here. And now corresponding to this vertical wave which is having depth is equal to 10 millimeter, so this surface will be visible to the observer, that is the rear end surface, but this surface of this vertical web, it will not be visible to the observer. So that is why, so we are going to have dotted line projections or the hidden line projections at a distance of 10 millimeter from the rear face, which is going to describe the uniform thickness of this vertical wave which is lying at the rear surface of the solid over here. Now we can see This T1 surface is this one. That is the top web carrying a central rectangular hole. So since this surface T1 happens to be parallel to the horizontal plane, so we are able to visualize true shape projections corresponding to the surface T1 into the top view projections over here. And now we can check this top portion. This will be visible to the observer into the top view projections over here. So even though this is an inclined surface, but it will be appearing like a foreshortened surface into the top view projections over here. So this surface we have marked as T2 surface. So T2 surface starts from this end and this completes the inclined top portion of the surface which we have named as T2. So into the top view projections, we have been able to obtain the apparent shape projections corresponding to the surface into the top view projections over here. So this way we have been able to obtain the orthographic top view projections corresponding to this engineering object over here. Now let us proceed to evaluate the right hand side view projections of the solid. Now we can check, as the observer is going to look at the solid from the right side, observer will be able to view the side view of this top surface horizontal web as a rectangular surface having depth is equal to 28 millimeter, height is equal to 10 millimeter. We can check the depth, it is equal to 28 millimeter and height is equal to 10 millimeter. So this rectangular surface will be visible to the observer, and we can check this portion, it corresponds to the depth equal to 28 millimeter over here. Similarly, corresponding to this vertical wave, one vertical rectangular web will be visible to the observer. So this portion of the rectangular web is visible to the observer. And finally, this is the inclined surface which will be visible to the observer from the right hand side view. And now since this surface S1, it happens to be parallel to the profile plane, so we are able to observe the true shape projections of the surface S1 into the right hand side view face projections over here. And another thing we need to observe, corresponding to this rectangular slot which is going to be available at a distance of 18 millimeter from the rear face, we can check this distance happens to be 18 millimeter from the rear face. We are going to observe the hidden line projections over here corresponding to this portion of the slot over here. So here we are able to observe a dotted line or a hidden line projections corresponding to this vertical portion of the slot over here. So this way we have been able to obtain orthographic front view projections, orthographic top view projections and the orthographic right hand side view projections corresponding to this engineering object whose 3D isometric projections they were available with us. So I hope that through this discussion you would have understood about the procedure, how do we evaluate the orthographic projections of the object when the isometric projections of the component they have been provided to us. So this is all for today. So we will be continuing with further discussion regarding few more illustrative cases of orthographic projections in the coming lectures as well. So thank you very much. Thanks a lot.